Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faiz Hakimi bin Abdul Manan. My metric number is 13DAD20F1049. Today I want to talk about my topic is manual transmission. I take this topic with my friend is Muhammad Ashraf bin Ibrahim. Okay, now I want to talk about introduction manual transmission. The transmission or trans-S provide the gearing need to reverse direction, so the vehicle can be driven backward. Engine crankshaft cannot reverse. Next, there is also a neutral position that stops power from reaching the drive wheels. The next introduction is three main function of transmission. Provide the various torque and speed need to move the vehicle under a variety of road and load conditions. Changing the gear ratio between the engine crankshaft and vehicle drive wheels be shift into reverse so the vehicle can move backward. Be shift into neutral for starting the engine and running it without turning the drive wheels. Transmission VS versus Trans-S. Vehicles are propelled in one of three ways. At first, by the rear wheels, RWD. Second, by the front wheels, FWD. Third, by the front and rear wheels, 4WD or AWD. Vehicle propelled by the rear wheels normally use a transmission. Transmission versus Trans-S. Front-wheel drive FWD vehicle are propelled by the front wheels. The Trans-S is the special power transfer unit commonly used on FWD vehicle. The Trans-S combine the transmission gearing, differential and drive S connection into a single case housing located in front of the vehicle. Next, four-wheel drive FWD vehicle typically use a Trans-S and transfer case. The transfer case mount on the side or back of the transmission. A chain or gear drive inside the transfer case receive power from the transmission and transfer it to two separate drive shafts. One drive shaft connects to a differential on the front drive S. The other drive shaft connects to a differential on the rear drive ace. Next, the construction of manual transmission. There was a output shaft, fifth gear, first gear, 1.2 synchronizer, second gear, third gear, 3-4 synchronizer, input clutch gear for gear, input shaft, counter shaft, input clutch gear, third gear, second gear, reverse idler gear, reverse gear, first gear, fifth gear synchronizer, speedometer gear. After that, the construction of manual transmission. First, most transmission have three basic shafts: the main shaft, output shaft, input shaft, counter shaft. The speed gears ride on the main shaft, also called the output shaft. The counter shaft is actually several gears machined out of a single piece of tin or iron. The counter shaft may also be called the counter gear or cluster gear. Construction of manual transmission. The main gears on the main shaft or output shaft transfer rotation from the counter gear to the output shaft. The main gear are also called speed gears. Speed gear freewheel around the output shaft until they are locked to it by the engagement of their shift synchronizer unit. Transmission lubricant. There are two types of grade normally used for manual transmission. Grade A pin 90, extreme pressure 90. For Trans-S, SAE 140, Society of Automotive Engineer 140 for transmission. Function of lubricant in the manual transmission. Lubricate gears and bearings to prevent wear, reduce friction and power loss, protect against rust and corrosion, remove particle from metal surface, help cool bearing and gears. And the last, construction of manual transmission synchronizer. Its main job is to bring components that are rotating at different speed to one synchronized speed. A synchronizer ensures that the pinion shaft and the speed gear are rotating at the same speed. The second major job of the synchronizer is to actually lock these components together. One synchronizer is placed between the first and second gear on the pinion shaft. Another is placed between the third and fourth gear on the main shaft. If the transmission has a fifth gear, it is also equipped with a synchronizer. Reverse gear is not normally fitted with a synchronizer. That's all for my present. Next, I give my present to my friend. It's Mama Ashraf bin Ibrahim. Thank you.
Assalamualaikum and hi, my name is Muhammad Ashraf bin Ibrahim. My matrix number is 13-80-20F1105. Today I would like to present the subtopic of automotive technology. I will continue for part 2 since my partner present for part 1. Okay, straight to the point. Gear shifting mechanism. There are 3 separate shift rails and forks. Each shift rail or shift fork is used to control the movement of a synchronizer, and each synchronizer is capable of engaging and locking two speed gears to the main shaft. The shift rails transfer motion from the driver control gear shift lever to the shift forks. Okay, look at this diagram. This diagram shows an interior view of a 5-speed overdrive transmission. Next, the gear shift lever is connected to shift forks by means of a gear shift linkage. And movement of the shifter moves a shift rail and shift fork toward the desired gear. This moves the synchronizer sleeve to lock the selected speed gear to the shaft. Okay, we go through to the power flow. The following sections describe the path of power to a typical 5-speed transmission. First, neutral. Second, first gear. Second gear. Third gear. Fourth gear. Fifth gear, and reverse gear. Okay, we go to the first one, neutral. When the gear selector is placed in the neutral position, the input shaft rotates at engine speed. The shaft's clutch gear is in mesh with the counter gear, which rotates on the counter shaft. The counter gears are in mesh with the speed gears. Because none of the speed gears are locked to the main shaft, the gears spin freely and no torque is applied to the main shaft. All gear changes pass through the neutral gear position. First gear. Power of torque flows through the input shaft and clutch gear to the counter gear. The counter gear rotates. The first gear on the cluster drives the first speed gear on the main shaft. When the driver selects first gear, the first or second synchronizer moves to the rear to engage the first speed gear and lock it to the main shaft. The first speed gear drives the main output shaft, which transfers power to the drive line. Second gear. When the shift from first to second gear is made, the shift fork disengages the first or second synchronizer from the first speed gear and moves it until it locks the second speed gear to the main shaft. Power flow is still through the input shaft and clutch gear to the counter gear. However, now the second counter gear on the clutch to transfer power to the second speed gear lock on the main shaft. Power flows from the second speed gear through the synchronizer to the main shaft, output shaft, and driveline. In second gear, the need for vehicle speed and acceleration is greater than the need for maximum torque multiplication. To meet these needs, the second speed gear on the main shaft is designed slightly smaller than the first speed gear. Okay, next, third gear. When the shift from second to third gear is made, the shift fork returns the first or second synchronizer to its neutral position. The second shift fork slides the third or fourth synchronizer until it locks the third speed gear to the main shaft. Power flow now goes through the third gear of the counter gear to the third speed gear, through the synchronizer to the main shaft and driveline. Third gear permits a further decrease in torque and increase in speed. As you can see, the third speed gear is smaller than the second gear. Fourth gear. In fourth gear, the third or fourth synchronizer is moved to lock the clutch gear on the input shaft to the main shaft. This means power flow is directly from the input shaft to the main shaft at a gear ratio of 1:1. This ratio results in minimum speed output and no torque multiplication. Fourth gear has no torque multiplication because it is used at cruising speeds to promote maximum fuel economy. The vehicle is normally downshifted to lower gears to take advantage of torque multiplication and acceleration when passing slower vehicles or climbing grades. When fifth gear is selected, the fifth gear synchronizer engages fifth gear to the main shaft. This causes a large gear on the counter shaft to drive a smaller gear on the main shaft, which results in an overdrive condition. Overdrive permits an engine speed reduction at higher vehicle speeds. In reverse gear, it is necessary to reverse the direction of the main shaft. This is done by introducing a reverse idle gear into the power flow path. The idle gear is located between the counter shaft reverse gear and the reverse speed gear on the main shaft. The idle assembly is made of a short drive shaft independently mounted in the transmission case parallel to the counter shaft. The idle gear may be mounted near the midpoint of the shaft. The shifting linkage moves the reverse idle gear into mesh with the first second synchronizer sleeve. Power flow through the input shaft and clutch gear to the counter shaft. From the counter shaft, it passes to the reverse idle gear, where it changes rational direction. It then passes to the first or second synchronizer sleeve. Rationally, a rotational direction is again reversed. From the sleeve, power passes to the main shaft and driveline. Yeah, that's all for today, I think. Thank you.